In this lesson, we're going to cover combination of functions, and then we're going to cover composite functions. So combinations looks much more difficult than it actually is. Basically what we're doing is, let's say we have two functions. We have f of x and g of x, and you want to add them together. It's written as f plus g of x. So all that really is f of x plus g of x. If we're subtracting, it's f minus g of x. So again, that's just f of x minus g of x. If you're multiplying, it's going to look fg of x, which is really f of x times g of x. And if you're dividing, it's going to be f divided by g, or f over g of x, which again is f of x divided by g of x. Okay, now we're going to be talking about the domain of all the functions, and just remember that when you are dividing, whatever function ends up at the bottom, that function can never have a value of 0, because that will make your function completely undefined. So we're just going to come in here and we're going to solve these problems. Right now, we're not going to worry about domain of any of these. We're just going to worry about actually solving them. So if I have f plus g of x, that just means f of x plus g of x. Now notice at the top, we told you f of x is 2x plus 1, and g of x is x squared plus 2x minus 1. So I'm just going to combine my like terms. I have an x squared here. I have 2x and 2x is 4x, and plus 1 and minus 1 cancels out. So I know that f plus g of x is going to equal x squared plus 4x. So that's my solution, okay? Now notice in the next problem, it's f plus g, same two functions, of 2. Well, I could work this out two ways. I could do a shortcut. Now that I've already combined them here, I could just say then that f plus g of 2 is equal to, and I could just plug the 2 in for the x here. So 2 squared plus 4 times 2. In other words, I'm just plugging it into this part of it. So this is going to equal 4 plus 8, or 12. And so I know that this function equals 12. So that's the way I could do it if I've already done this step. Now, if I just happen to come to this problem and I haven't done that other step, and all they're asking me to do is, all I have is this, then I could also come back here, and I know that this is f of x plus g of x. So this is f of 2 plus g of 2. So I could basically, again, take this first equation and do 2 times 2 plus 1. And then g of 2 is 2 squared plus 2 times 2 minus 1. And again, I could do the math. I'm going to get 4 plus 1 is 5. I'm going to get here, this is 4. Plus 4 minus 1 is 7, and 5 plus 7 is 12. And I'm going to get the same answer, okay? So that's also something you could do. So I'm going to now go to the subtraction problem. And again, I have f minus g of x, so I know that's f of x minus g of x. Be careful when you're subtracting, because remember, you're going to have to distribute that subtraction symbol. So f of x is 2x plus 1. G of x is x squared plus 2x minus 1, but now notice I have to distribute this minus. So it's going to be 2x plus 1 minus x squared minus 2x plus 1. Again, I don't have any other x squareds. I'll combine my like terms. The two x's cancel out. And then I have plus 2. And so I know this is the solution to this problem, minus x plus 2. Again, here now, I have f minus g of 2. So f minus g of 2 is going to be, I'm going to take this equation, and it's going to be the opposite of 2 plus 2. So minus 2 plus 2 equals 0. And so 0 is my solution. Again, I could do it the longer way. I'm going to leave the solution there, but I could do it the longer way. I could do f of 2, and I could even do it like this. I could do f of 2 is 2 times 2 plus 1, which is 5. And then I could do g of 2, which I know is going to be 2 squared plus 2 times 2 minus 1. So that's going to be 7. And then I know that f minus g of 2 is going to be the f of x minus, or the f of 2 minus the g of 2, which is negative 2. So I could do it many different ways, but you understand the gist of it, and that's how we solve these composite. So now I come over to here, f times g of x, and again, same idea. I know that if this is going to be f of x times g of x, and so f of x is x squared, and g of x is x minus 3. So I know I'm going to multiply. So I'm going to get x cubed minus 3x squared. And that's the answer. Now again, if I have f of g, or fg of 4, right, that's again f of 4 times g of 4. If I want, I could just use this one, right? I could just say, okay, 4 cubed minus 3 times 4 squared. 64 minus 4 squared is 16, and that's 48. And so that would be 16. So I know my answer is going to be 16. However, if I want to do it the longer way, I could do f of 4 times g of 4. And again, f of x is x squared, so this is going to be 4 squared. And g of 4 is going to be times 4 minus 3. So 16 times 1, or 16. Again, I'm going to get the same answer no matter what. And then we get to here where we're going to do division. And this one's a little bit more challenging. You can notice that, you know, even the functions are a little bit more challenging. So again, I know this is f of x divided by g of x. So f of x is the square root of x, and g of x is the square root of 4 minus x squared. Now, this is actually the answer, okay, for this. I'm not going to ask you to rationalize this denominator or anything like that. You can leave the answer like this, okay? Now, the issue comes in, and it wants you to find the domain, okay? And so when you're finding the domain of these mixed functions, you know, you have to kind of know your domain rules, right? All the other examples on the other pages were linear or quadratic functions, which all have, and there were no denominators. And so basically, it was all real numbers. The domain of all the previous problems was just all real numbers. And so what I have to do is I have to find the domain of the numerator, or the first function, f of x. So the domain of this, I know, is that x has to be greater than or equal to 0. The denominator is where this gets tricky, because my g of x, right, normally I would just have to say, okay, well, I know that 4 minus x squared has to also be greater than or equal to 0. The issue is that, remember, that 4 minus x squared has to just be greater than 0, because since it's in the denominator, it can't actually equal 0. And quadratic inequalities, remember the pattern. We set it equal to 0. We solve for x squared, right? So we're going to get x squared equals 4. So x equals plus or minus 2. And then we have to graph it. And we have to find out which piece of this are we in, right? Here's negative 2, here's 2, and we're going to plug in 0. So does 4 minus 0 squared, is it greater than 0? If it's true, and it is, this is the section that is the solutions. If it's false, it would not be. Once we know that the solutions are in here, we know the pattern goes like this, and we can exit out the other ones. So the domain for the denominator, okay, is going to be that x is, or here, let me fix that. The domain is going to be from 2, or from negative 2 to 2, and it can't be including, because remember, it can't equal 0. So it's going to be, remember, it's always open. So now that's my domain for my denominator portion, or my g of x in the denominator spot. My domain for my numerator, again, here's 0. It's going to be a filled in circle up and to the right, and the overlap is going to be the domain of my function. So the domain of my entire function is going to be from 0 to positive 2, including 0, but not positive 2. Okay, so it's going to be in this space. Okay, this is out because it doesn't satisfy the numerator domain, and this is out because it doesn't satisfy the denominator domain. So it's a little bit tricky. Now let's go and try the number 8. So again, this is going to be g of x over f of x. So now again, notice that f of x is the one in the denominator spot. it's the one that's going to have more restrictions. Okay, so once again, we come over to here. This is the actual solution. Okay, that's the combined function. Now we have to work on domains. So again, the domain of g of x here, okay, if g of x is the square root of 4 minus x squared, I know the domain of this is going to require a little bit of work, right? I've got to do 4 minus x squared is going to be greater than or equal to 0. And now I have to set this up. These quadratic inequalities get set up as equations. We do the math, right? And I know that x is plus or minus 2. Again, I'm going to come over to here. I know I have minus 2, I have plus 2, and I'm going to pick a point like 0. I'm going to plug it in here, and I'm going to say 4 minus 0 is greater than or equal to 0, and it is. So my answer is in this section, but this time it's brackets, because again, it can equal 0 when it's in the numerator spot. So my domain of g of x is going to be negative 2 to 2 with the brackets. Now again, my denominator now is a little bit different. My f of x is the square root of x, and normally I know that my domain is going to be that x is greater than or equal to 0, but because it's in the denominator, it has to be greater than 0. So it can't include 0, but it goes to infinity. So my domain here, if this is 0, it's going to be an open circle, and it goes up and to the right as well. And again, my function, the domain for my entire function is going to be the overlap. Okay, so this one, the blue goes through like that. Then the denominator is the red, and then my function domain is going to be from 0, not including 0, all the way to 2, including 2. And that's going to be, so it's just a little bit different. Notice it's kind of similar numbers, but in this one, it includes 0 and doesn't include 2, and in the other one, it doesn't include 0, but it does include the number 2. So it's kind of interesting. And that's all because of what was in the bottom spot, the denominator. Again, we keep going, and now we get to composite functions. And composite functions are going to be a little bit different. Now, I want you to understand this does not mean multiplication, okay? This is read as, I don't even like to put the dot in there. It's f of g of x. And what it really means is f of g of x, like that, okay? Like this. So what happens is whatever g of x is, you're plugging it in for x into the f function. Or in this case, whatever f of x is getting plugged into the g function for x. So again, I'll show you how to do that. But what happens is this. Let's say that you have f of g of, let's just say x, right? Let's call it that. If f of x equals x, let's say x plus 2, and g of x equals x squared, then if I do f of g of x, what I'm doing is f of, and instead of g of x, I'm putting f of x squared. So I go to my function for f of x, and I'm going to plug x squared in for that x, okay? We'll do some problems and you'll see, but all I'm really doing is I'm plugging in whatever g of x is into f of x. Okay, so what I'm going to do is I'm going to take this, and I know that this is f of g of x, okay? And I know that f of x equals, let me see if I can do this better, okay? F of x normally is x plus 2. If I substitute this x for f of g of x, right? What I'm subbing in here is whatever g of x is. I'm putting 4 minus x squared in there. And so when I go to my problem, whatever x is, my expression, I'm going to put 4 minus x squared in for x, and I'm just going to do the math. Okay, so f of g of x is going to equal minus x squared plus 6. And that's it. Right, so I just plugged g of x, whatever g of x was, okay, I put it there, so it went into wherever x was, okay, and then I just combine and solve. So let's do another one. If I come over to here, and I have g of f of x. Okay, first of all, let me write out g of x. I know that g of x equals 4 minus whatever x is squared. So if I'm going to do g of f of x, right, then it's still going to be 4 minus, x squared, right? Except now, what's f of x? Well, f of x is x plus 2. So wherever there's an x, I'm going to put x plus 2, okay? And then I come over to here and I do 4 minus, and I know this is x squared plus 4x plus 4. If I'm subtracting the whole thing, I have to distribute that minus. So 4 minus x squared minus 4x minus 4. Combine my like terms, and these cancel. And so I know that g of f of x is equal to this. And that's the answer. And then I go and do number 11. So now number 11 says, well, what's g of f of negative 2? Well, again, I already found g of f of x, right? G of f of x equals this, right? Negative x squared minus 4x. So now if I want to do g of negative 2, right? Or let me write it the right way. I could do g of f of negative 2, I can just plug negative 2 in here. Okay? And so I know that's going to equal the opposite of negative 2 squared plus 8. So it's going to be 4. So I know my answer, g of f of negative 2, is going to be 4. Another way that I could have done that, let me kind of erase this stuff, it's getting crowded. Another way that I could have done it is I could have just done, it would have been longer, but I could have done f of negative 2 first, right? Found that, then g of that. It would have been a little bit longer step. I think this is probably the best way for us to do it. So g of f of x, get this simplified answer here, okay? And once you have the simplified answer, then you can go ahead and just plug your negative 2 in, okay? Again, here's some more examples. So f of g of x, okay? I know that f of x equals 2 times x plus 5. So this would be, if I plug g of x in here, I know g of x is 4x squared plus 1. So this is going to be 4x squared plus 1 in here. I'm going to distribute my 2, 8x squared plus 2 plus 5, and it equals 8x squared plus 7. So there's my solution. Okay. And again, g of f of x. Again, g of x, the formula for that is going to be 4 times x squared plus 1. So if f of x is equal to 2x plus 5, then that's what I'm going to substitute in for x. And I'm going to get 8x plus 20. Oh, no, sorry. I have to square that first, right? Order of operations matters here. So I have to do 4 times, this is going to be 4x squared plus 20x plus 25 plus 1. Multiply by 4, so 16x squared plus 80x plus 100 plus 1. 16x squared plus 80x plus 101. So that's what g of f of x is going to equal. Okay. And then the last one is, what is f of g of negative a half? And so again, f of g of x, we already solved for that. That was 8x squared plus 7. So f of g of a half, right? So again, f of g. So f of g of x, we already have that combination. So if x is a half, or negative a half, we're just going to plug it into here. And I'm going to get 8, negative a half squared is a fourth. I'm going to get 2 plus 7 is 9. And so my answer is 9. In this process, if I'm solving for the same type of composite functions, but I'm looking for domain, okay, what I'm going to be doing is I'm going to find the domain of g of x, and then I'm going to find the domain of the final answer. So I'm going to find the domain of the inner piece. I don't have to find the domain of f of x, let's say, because that's going to be taken into account with the final one. So when I'm finding domains here, since it's f of g of x, since g of x is the internal one, I have to find the domain of this, and then I have to find the domain of the final answer. So again, this is f of g of x. Let me solve this first. I know f of x is x squared minus 9. So if g of x is equal to the square root of 9 minus x squared, then that's what's going to replace here. So square root of 9 minus x squared minus 9. I know my square root and my squared cancel. 9 minus x squared minus 9. The 9's cancel. And I get that my function value is minus x squared. Okay? So I come over to here. So f of g of x equals this. That's the first solution. Now they want the domain. So again, I'm going to find the domain of the internal piece, which was g of x. So if this is 9 minus x squared, again, I know that 9 minus x squared has to be, it's not in a denominator, so it just has to be greater than or equal to 0. I'll set it equal. I'll solve for x squared. So I know that x is plus or minus 3. And I know that since it's an inequality, I have to set it up like this, and I have to find my domain here. So again, I'll go back to this part right here, and I'll plug in a number. I'm going to plug in 0. So 9 minus 0 is greater than or equal to 0. That's true. So this is a solution set. This is not, and this is not. So my domain of g of x is going to be a solid circle, and it's going to be all this area in between. Now I have to go to my final solution here and see what my domain is of that. And my domain of the opposite of x squared is going to be all real numbers, okay? So my domain is actually everything. So what I need for this problem is I need the overlap. So I know it's going to overlap from 3 to 3, and it's this area in here. So my domain of this problem is going to be negative 3, 3 with brackets, because it's the overlap. Okay, last problem. I'm going to come over here, and I'm given these. I have f of g of x, and then find the domain. Again, the inner one is g of x, so I'm going to need the domain of this, and I'm going to need the domain of the final answer. So again, I'm going to start out. I know f of g of x. I know f of x equals the square root of x. So f of g of x means that wherever the x is, right, I'm going to put in x squared plus 4. So it's the square root of x squared plus 4. Again, I know that I have to find, well, this is my solution, right? So this is the answer. So f of g of x equals the square root of x squared plus 4. That's my answer. Now I have to find the domain of the inner portion. G of x is x squared plus 4. Well, the domain of this is all real numbers. There's no restrictions here. So my domain is all real numbers. And now I go to my solution, my composite, and I have to find the domain of that. So what is the domain of x squared plus 4? Well, I know this is going to end up being all real numbers. And you might say, well, how do you know that, right, without doing anything? Well, notice that anything squared is going to be positive, and a positive number plus a positive number is going to give me a positive number. If you had worked it out and you said, well, I know that this has to be greater than or equal to 0, you would get x squared has to be greater than or equal to negative 4. Well, first you turn it into an equation, right? And you'd get x equals plus or minus 2i. So yeah, there's imaginary component. But if the only restriction is imaginary numbers, then you know all real numbers are solutions. So my domain of both of these is all real numbers. So again, the domain of the solution then is going to be all real numbers as well. Okay, so it's in interval notation. And so that's it. So again, it's just take your time, work it out step by step. You're going to do great.